The birth of a new machine. We at Pyramid call it Project Jolt. This video will give you an overview of features and capacities of the Jolt system. The Jolt system was created to fill the market's demand for a mainframe alternative. It evolved from the Model 90X family, followed by the 9000 series, then the MIS server series, leading to the Jolt system. The Jolt machine features increased speed and capacity. The Model 90X family operated at 6 MIPS. The 9000 series increased the speed to 28 MIPS. The MIS server extended the 9000 series speed to 768 MIPS. The Jolt machine is now one of the fastest machines on the market, with a speed significantly over 1000 MIPS. The system achieves speed through its new design and components. The system's major components are housed in 2 cabinets: the core cabinet and the I/O cabinet. The core cabinet houses 3 different types of boards. One board type, the DPU or Dual Processing Unit board, accommodates 2 MIPS R4400 CPUs. Each CPU has its own fast cache memory. This design contributes significantly to the increased speed of the Jolt system. The core cabinet can house as many as 8 DPU boards, each with 2 CPUs, for a total of 16 CPUs, which comprise the processing engine of the system. The system memory, DRAM, is located on the MCAU board. The MCAU board is another type of board housed in the core cabinet. Memory SIMs are installed on the board in banks. Each MCAU combines main store memory, memory controller, and array on the same board. This new architecture provides multiple controllers for multiple arrays, another factor contributing to increased speed. Each MCAU can accommodate up to 1 gigabyte of memory. The last type of board in the core cabinet is the RXI board. The RXI, R-Bus to Extend Bus Interface, is the interface between the core cabinet and the I/O cabinet. I/O devices consist of disk drives, tape drives, printers, communication devices, and networks. The RXI board enables the machine to address all peripheral buses concurrently, a factor that increases the system speed dramatically. This is accomplished through the use of 4 Extend buses. Each RXI connects to 2 independent Extend buses, Extend A and Extend B. Functions take place concurrently over 2 or more buses. All disk drives, tape drives, printers, communication devices, and other peripherals can operate with overlapping instructions due to the new Extend bus design. The 3 types of boards in the core cabinet, DPU, the Dual Processing Unit, MCAU, the system memory, and the RXI interface from the processors to the peripherals, need to be located in particular slots in the core cabinet. Slot locations will be covered after the following discussion of the I/O cabinet. The I/O cabinet houses the Extend bus backplane and 7 types of boards that fit into the card cage and allow connection to all system peripherals. Cabling connects the RXI board in the core cabinet to the Extend bus backplane in the I/O cabinet. One type of board in the I/O cabinet is the Xvi board. The Xvi board accommodates the insertion of standard third-party VME boards into the Extend bus subsystem. 4 types of VME boards plug into the Xvi board. The SCSI, or SCSI host adapter board, can connect to disk drives, tape drives, and with optional daughter cards, line printers. The ISC-2 board synchronizes serial data communications protocols such as X.25, BiSync, and SNA. The FDDI, Fiber Distributed Data Interface Network board, allows connection to fiber optic devices. The last type of board that plugs into the Xvi board is the ILC-T token ring. It is the interface to a token ring network. Two other boards, both Pyramid products, fit directly into the Jolt I/O cabinet card cage. They are the HFI, Host Fiber Interface Board, that supports AT&T's Data Kit and ISDN, and the DEN, Dual Ethernet Board, that allows connection to an Ethernet network. An additional board, the AXI, located on the back plane, distributes system clocks to all slots in the I/O bay. The AXI cable carries the system clock signal from the core backplane to the AXI board in the I/O cabinet. You have seen the two cabinets and associated boards that comprise the Jolt system. There are 14 slots to house the three different types of boards in the core cabinet. Slots number 4 and number 11 are used only for debug of the system during manufacturing assembly and are located on the back side of the backplane. The purpose of this method is to eliminate the necessity of using an extender board to gain access to the computer's components during debugging. Because of the increased speed of Jolt CPUs, a new system was needed to eliminate the electronic noise, however slight, which may affect debug results. Slot number 4 is used to debug both the DPU and MCAU boards. Slot number 11 is used to debug the MCAU and RXI boards. Slot number 11 is unique because it allows an operator to drive the system clocks from this slot for debug of the clock driver circuitry. Slot number 13 must contain an MCAU memory board. The board in this slot is the source of all clocks in the system. The MCAU board must not be installed in slot number 2. There must be at least one DPU board to operate the system. The first DPU board should be installed in either slot number 2 or slot number 3. The console terminal can be physically connected to DPU boards only in slot number 2 or slot number 3. The RXI boards should be installed at either side of the core cabinet, in slot number 1 or slot number 14, or both, depending on the physical location of the I/O cabinets. More than one I/O cabinet can be connected to the core cabinet. When a large number of peripherals are connected to the core cabinet, both slot number 1 and slot number 14 are used by RXI boards. A third and fourth I/O cabinet can be connected to extend the system further. The remaining slots in the core cabinet can be used by DPU boards and MCAU boards in any combination as needed. The air circulation system keeps the machine cooler than any of its predecessors. The improved cabinet design allows for easier access to all system components. The Jolt system is another proud accomplishment of a company that is a forerunner in today's leading-edge computer technology. With the introduction of the 90X family, Pyramid developed and marketed the proprietary 32-bit processor and the very first mini-computer to use RISC architecture. In the 9000 series, Pyramid introduced buffers and instruction cache while expanding the system to 4 CPUs. The MIS server expanded all this even further by placing 2 CPUs on a board and allowing up to 24 CPUs. Now the Jolt machine breaks all speed barriers adds fast cache memory to every CPU, increases capacity of both main memory and mass storage, has a CPU bandwidth 5 times larger than the MIS server, boasts a total memory of more than 4 gigabytes using multiple memory buses, allows connection of up to 512 SCSI devices, utilizes 1 terabyte of disk space, 4 times more than the MIS server, and can accommodate over 2,000 users at astonishing speed. Jolt is Pyramid's internal code name for the product. The Jolt system was designed to meet the expanding demands for massive database application needs for Pyramid customers.